Right, hello guys and welcome. Today I'm again delighted to have here with me Abdallah. Abdallah, welcome.
Hi, Cameron. Yeah, hi
Yeah.
everyone. So my name's Abdallah Wahishi. So this is my YouTube channel actually. So a lot of you will know me from Abdallah Maths Tutoring 2021. So I make videos for Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths. If you find this video useful, then I'd love it if you could press the subscribe button, drop the video a like, and also press the bell icon so you don't miss out on further uploads. Such as videos like this. But I'm going to hand you over to Cameron now. So thank you, Cameron, for introducing me.
Yeah, thank you, Abdallah. So today what we're going to do, guys, we're going to go through paper number 2 of the foundation tier of the November 2018 AQA spec. Okay, so we're going to go straight into it. Okay, we're going to get started off, and Abdallah is going to take you for the first question.
Question 1, so it is a perimeter question. Here is a rectangle. Work out the perimeter. Circle your answer. Well, perimeter, guys, means the distance around the whole shape. So this is 7, this is 5. A rectangle, so opposite sides have the same length. So this is going to be 7, this is going to be 5. So the perimeter, guys, is 7 plus 5 plus 7 plus 5. So writing out here, so 7 plus 5 plus 7 plus 5. So 7 plus 5 is 12. And then add 12 again, okay, is going to be 24. So I'm going to circle 24 centimeters, guys. So I'm going to circle option 2, guys. Number 2, circle the number that is greater than minus 0.9. Well, minus 0.9, guys, is equivalent, so it's the same as minus 9/10. Because if you think about 0.9, so 0.9, okay, is the same as 9/10 on your calculators. Okay, so therefore minus 0.9 is going to be equal to minus 9/10. So just checking this on our calculator. So if I type in minus 9, if I type in that, then it comes up with minus 9/10. Okay, so that shows me, okay, so that is the equivalent fraction. So it can't be that option there, guys. So I'm going to cross off that option there because it has to be greater than, okay. Looking at this one here, well, minus 0.91 actually is actually smaller than minus 0.9 actually, because if I think about it, I've got minus 0.90, so I can add as many zeros after the 9 as possible, and the number remains unchanged. Okay, so looking at the second decimal place, that one's smaller than the 0, so therefore this number is bigger than this number, so it can't be that option. Looking at this one, guys, I've got minus 0.901. So comparing this one here, 0, 1, okay, that one is smaller than that 0, so it can't be that option there. So it leaves us with minus 0.89. So minus 0.89 is larger than minus 0.9, okay? Right, guys, question number 3, it says simplify 8x minus 3 plus 6x. Circle your answer. So collecting like terms. So 8x and 6x are what I call like terms. So 8x, guys, so 8x add 6x is equal to 14x. 8 add 6 is 14. And then we've also got the x on the end. So it's 14, and then I've got the minus 3 as well. So it's 14x minus 3. So I'm going to circle option number 3. So that's question number 3, guys. Question number 4. Okay, what is the angle of turn clockwise from southwest to east? Now, the way that I remember the compasses, guys, is never eat shredded wheat. Okay, so it sounds a bit cheesy actually. So never eat shredded wheat. Now it's saying southwest. So southwest is bang in the middle there. Okay, so this angle here, guys, we can see is going to be 45 actually, because this whole angle is going to be 90 because it is a right angle, and then I'm going to be adding on 180 because angles on a straight line add up to 180. So I've got 180 add 45 degrees. Okay, so working out our answer, 0 add 5 is 5, 8 add 4 is 12, so 2 carry the 1 add 2 is 2, and I remember my degree symbol, so circle my answer is going to be option number 3. So that is the bearings question.
Okay, thank you, Abdallah. I'm going to carry on now with question number 5, which is about Lucy. Now, Lucy works for 37 hours per week. Okay, her weekly wage is £303.40, £303.40, sorry, and she receives a pay increase of 25p per hour. Work out her new weekly wage. So her weekly, her weekly pay increase is going to be worked out by making this 25p per hour into a multiplier. Now, I'm going to make this into 0.25 because it says pennies. So it's going to be 0.25, and I'm going to times that by how many hours she works to see the increase. So she works 37 hours per week, and she gets 25p per hour. So if you do 0.25 times by 37, that would tell me how much money she gets as an increase. So she gets £9.25 as an increase. I'll just show you that on the calculator as well. So you get 0.25 times by 37. So this is what she gets increased onto her money. So if it's increased onto her money, I need to add it on to her new weekly wage because it's her new one. Now this is her original. So it's currently 303.40. So I'm going to add that on as 9.25. Now, it is a calculator paper, but, you know, we can easily do this in our heads. 9 plus 3 is 12. 0 plus nothing plus the 1 is that 1. And the 3 plus nothing is 3. So that's 312.65. And again, just to show you on the calculator, just to make sure that I've got no errors anywhere, just checking my answer as well, which is always good to do on a calculator paper. You've got it for a reason. Make sure you use it. Plus 9.25. It's going to actually give me 312.65. So I'm working out an increase onto our number. Okay, so that's question number 5. Number 6 then says that complete the bank statement. So what you've got is you've got bank statement, and this will come in useful later on, guys, when you actually start using your bank statements. And some of you might already have bank things like that when you're looking at credit and debit. And you need to just kind of look at what happens here. So you've currently got a balance of 1140, which is £1,140.79p, and then you get a debit. Now here we've got a credit, we've got a debit. Now our credit and debit is our credit is going in and our debit is going out. So what we need to look at is we need to actually look at this being taken away from it. Okay, and if you didn't know what credit and debit meant, there's quite an easy way of looking at it as well, you're able to work it out. Well, if your balance is 1,140.79 and you get car repairs, well, you're not really going to be getting money for car repairs. You're going to be paying the money. So you know that if in doubt, you're going to be taking the money out from that. And also salary, well, you know that you get a salary. So that must be the one that's coming in. So credit must be the one that's coming in. Debit must be the one out. So if it's coming out, it's being taken away from this original. So I can easily do that on my calculator. 1140 take away 256. What I can do is 1140.79 take away 256.00, and that gives me an answer of 884.79. So I can put in my so I can put in there 884.79. And then again, I lose some more money. I now got to pay my gas bill for £87.31. So now taking that out, 884 take away 887, sorry, not 800, 87.31. That gives me an answer of 797.48. So we've now got a balance of 797.48. And then we get a big salary increase to this price here. Okay, so now we get an increase. So we're going to add that on there. So again, just keeping our answer in there and then clicking add. So it will be answer plus it. So we didn't have to put the whole answer in again. 2069. 2069.75 is equal to 2867.23. That's 2867.23. So what you're doing there, you're getting 3 marks being able to complete each of these 3 here. Okay, so just remember that in is a credit and out is debit. Question number 6b then says write down the meaning of debit as used in the bank statement. So as it says as used in the bank statement, we need to link back to our bank statement that we've just worked out. And so like I've told you, debit is going out. Okay, so the money's being taken out. So anything along the lines of you being able to describe that the money's coming out, that will get you the mark. So money being taken out of the account, I would say. There could be ways that you could write, say the money's being subtracted out of it, you're paying for it, the money being, you know, subtracted out of your bank, and anything like that will give you the mark for that. Okay. Okay, question number 7. I'm going to hand back over to Abdallah for question number 7.
Okay, question number 7, guys. So line AB is drawn on the grid. A is the point 0, 2, so 0, 2, and B is the coordinate 6, 5, so 6 across and 5 up. Part A, question number 7A, work out the coordinates of the midpoint of line AB. Well, so to work out the midpoint, actually, so it's adding the x coordinates together and then halving your answer. So adding the 2 x coordinates together and then halving your answer, and then similarly adding your 2 y coordinates and then adding your answer. So 2 plus 5 over 2. So guys, working this out, guys, 0 plus 6 is 6. So I've got 6 over 2, and 2 plus 5 is 7, so 7 over 2. 6 over 2, guys, is going to be 3. 3 is going to go there. 7 over 2 is same as saying 3.5. So that is the midpoint of the line AB. So it will look somewhere here. So well, it will not be somewhere here actually. So it is going to be bang on there. So I'm going to just call that M actually for midpoint. Okay, so that's the midpoint of line AB, guys. Guys, part B, okay, so C is another point on AB. C is closer to B than A. The coordinates of C are whole numbers. Work out the coordinates of C, guys. So C is closer to B than A. Okay, so it's closer. So C is closer to B than A. Well, I can see here, yeah, that so obviously by estimating it, that's going to be 4, 4. Now we can clearly see visually, okay, that this line is closer to A than it is to B. So just drawing my arrows here. So I'm going to change color here. Okay, so we can see that that line here, okay, so point C, guys, that line is closer in length and in than it is with this line. So C to A. So we can clearly see that visually that that C is closer to B than A. So that's my answer for that. So it's going to be 4, 4 for part B, guys. Okay, so that's my answer for part B. Right, guys. Question 7C. On the grid, actually, draw a line from the point 0, 0. So that's the origin that is parallel to AB and 2/3 as long as AB. Okay. So going back to the graph, guys. So drawing our graph here, actually. So the distance going across, guys. So distance AB, actually. So it's worked out by saying I'm going to go across 1, 2, 3, 4, 5, 6. So 6 squares across. And I'm going to go up 3 squares. Now, parallel lines means that they never meet. So it is going to be the same direction as the line AB. Okay, so parallel lines, they never meet actually. So imagine that you have like train tracks. So those lines never meet. So 2/3 of this line here actually. So I can work out 2/3 of 6. So 2/3 of 6 is 6 divided by 3 times by 2. So 6 divided by 3 is 2 times 2 is 4. So it's going to go across 4, our new point. So I'm going to put a dot there so I know. And then 2/3 of the height, which is 3. So 2/3 of 3 is 3 divided by 3, which is 1, times it by 2 is going to be 2. Okay, so it's going across 4 and up 2. Okay, so it's going to look, so changing my color here actually, so to make it a bit more visibly clear. So it's going to be 4 across and then 2 up, guys. So it's going to look something like that. So that is exactly parallel to that line there actually, and it's 2/3 of that amount. Okay, so that is my line of AB. Sorry, that is my line for AB, and it goes through the origin, which is 0, 0, and it's 2/3 of that amount, guys. Okay, so that's working out the line there, guys.
Okay, so question number 8 then. Thank you, Abdallah. So question number 8 says Lena or Lena, not sure how you pronounce that, is at gym. She will use each of these pieces of equipment once: a rowing machine, a stepper, a treadmill, and a bike. Sounds like Abdallah, he's just been to the gym. Lena will use the rowing machine first. List all the possible orders in which she could use the 4 pieces of equipment. So we know that Lena or Lena, or however sorry you say her name, will use the rowing machine first. So we know that our selection has got to be rowing machine first. So we're going to write our possible solutions, possible orders, or listing the outcomes that could be with the rowing machine first. So rowing machine, I'm then going to do it in the order that it's given me. So rowing machine, stepper, and then the treadmill, and then bike. I'm then going to swap the treadmill and the bike around. So I'm going to do rowing machine, stepper, bike, and treadmill. And now actually I've done all of my solutions for R and S, which is the rowing machine and stepper. So I'm now going to do the rowing machine and then the treadmill. Rowing machine, treadmill, stepper, bike. Swapping those around: rowing machine, treadmill, bike, and then stepper. And then I've finally done all of my solutions for them. So you can see clearly that there's 2 solutions for each one. So you're going to need 2 for each particular thing after your rowing machine. So then I'm going to do rowing machine, and then I'm going to do bike. Rowing machine, bike, stepper, treadmill. Rowing machine, bike, treadmill, stepper. So I've listed all of the possible outcomes that possibly could happen after rowing machine first. So you can see 2 + 2 is 4, + 2 is 6. So I should have 6. 1, 2, 3, 4, 5, 6. So I've got 6 there. So these are all the possible orders which you could use the 4 pieces of equipment. Okay, so she has 4 pieces of equipment, but she's got to use the rowing machine first. That should be your first letter for each one. And then obviously you swap your second letter for each and then change these around. Okay, hopefully that makes sense. Question number 8B then says that the table shows how long Lena spends on each piece of equipment. Okay, you've got 15 minutes, 30 minutes, 35 minutes, and 1 hour, 30 minutes. Lena starts on the rowing machine at 1:50 p.m. She has a break for 4 minutes between pieces of equipment. What time does she finish on her last piece of equipment? So what you've got here is actually her starting on the rowing machine here at 1:50, and she's adding on 4 minutes between each bit of equipment. So we're adding on 3 lots of 4. We're not going to add a 4 onto here because that's her last piece of equipment, and it says between. So it doesn't say after each one, okay? There's between. So obviously she isn't going on to any other equipment after the bike. She's obviously then leaving the gym. So she doesn't need to add another 4 onto that. So what I'm actually going to do is I'm going to actually get my calculator out. And because it's calculator paper, I can obviously do this. So what I'm going to do is I'm going to add up the total time first of all. So I've got 15 plus 4 plus 13. And then she's got a break of 4 minutes. And then plus 35, and then plus 4, and then she's got 1 hour and 30. Now, I can't really write 1 hour 30, but what can I write that in minutes? Well, 1 hour is 60 minutes, plus 30 is 90. So plus 90 minutes, which is plus the 90, and that gives me a total of 165 minutes. So 165 minutes is the total. So total is equal to 165 minutes. Now, we want to know that in hours. Well, we know that 60 minutes okay, is an hour. So 60, okay, goes into 100. Well, that's 2 hours is 120. So we know it's going to be 2 hours. And then how much have we got left over? Well, that's 40 minutes plus the 5 is 45 minutes. So 2 hours and 45 minutes. Hope that makes sense. So 165, well, 120 is 2 hours. Well, 65 take away 20. That leaves 45 minutes. So that's 2 hours and 45 minutes. Hopefully that makes sense, guys. She's got 2 hours, 45 minutes. And you want to know what time she starts on her finish. So she finishes on her last piece of equipment. So her starting time, we need to work out. Well, we already know it. It's 1:50. So she started at 1:50 p.m. and we're adding on 2 hours and 45 minutes. So added on 2 hours and 45 minutes. Now this will look a little bit weird because you can't have no longer than 60 minutes, but we'll work it out after. So 5 plus 0 is 5. 5 plus 4 is 9. 2 plus 1 is 395. Now we can't have 395s. We know that's 3. And then obviously that's 60. So that takes it. So what's that? Well, that's another hour. So that's 1 hour. What's 95 minutes into? Now that's 1 hour and 5 minutes. So 1 hour and 5 minutes to 3. So that's obviously going to be 4 hours because obviously the 3 plus the 1. So that gives you 4 hours and then 5 minutes. So that's actually going to give you the 4-5, but also you've got a 30 there as well because the 95 is 30 minutes. Sorry, guys. So 60 take away 30 plus the 5 is 35 minutes. You're actually going to leave at 4:35. Okay. So what you've got is you've got a starting of 150 and you're adding on 245. Well, 95, well, 60 is 1 hour. And then how much have you got left over? Well, you've got 30 minutes left over because 60 to 90 is 30 minutes. And then you've also got a 5, so that's 35. So 1 hour and 35 to 3 is 4:35. Hopefully that makes sense, guys. I don't want to confuse anyone with that. And I know it looks a little bit weird with having 95. Well, that's just 1 hour and 30 minutes. Okay, cool. Okay, so question number 9 then is interpreting composite bar charts. So what you've got is you've got the table shows the number of messages Sam received each day for 5 days. Okay, so you got number of emails and you got number of texts. So he or she has got the number of emails and messages that she's got, or he, on Monday, Tuesday, Wednesday, Thursday, and Friday. So Sam draws a composite bar chart to represent the data. He has drawn, okay, so he has drawn the bar chart for Monday, the bar for Monday, sorry. So you've got number of messages received, and then you've got the days across here, and then you've got messages received. And you've got a key here is emails and text. So you can see a composite bar chart puts 2 sets of data together in 1 bar. Okay, and what I mean by that is you can see this bar on Monday. It's got both emails and it's got both texts in. But this key illustrates that. So you can see that we can actually say, well, how many emails did he get on Monday? He got 12 emails on Monday. So that must mean that it goes up to 12 here with this darker color because he's made his key that. Now, obviously, we can't make our key exactly the same to our examiner. So we can just make a new key next to it. So what I'm going to do is I'm going to do my key now. So what I can do is I can do the number of emails, which is 8 for Tuesday. So I can go up to 8, okay, which is here. And I can draw the same sort of width bar there. It then gets 6 new texts. So I'm going to add on 6 from 8. Okay, now that's 14. So my total must have to be up to 14, which is here. Okay, so I'm actually going to go up to 14 in total because I've obviously got another 6 messages as well. Okay, hope that makes sense. Wednesday's got 10, so I'm going to go up to 10 for Wednesday. And that's going to be the number of emails. Oh, sorry, guys. Number of emails for Wednesday is 10. And then the number of texts you get is 3. So that's obviously 3 plus the 10, which is 13. That's going to be in between 12 and 14, which is about roughly approximately there. That's about good as it's going to get. Next one, Thursday, 6 and 6. So that's 12. So I can do my 6 first of all. And then I can do my other 6, which is going to be the 12 here. And then finally, Friday is 12 and then plus 4. Which is going to take me up to 16. And now I know that I can't leave it like this because this looks a little bit weird because obviously the key's different, but that doesn't really matter. But obviously I can't have these because these look exactly the same. So what I'm going to do is I'm just going to make a new key. So my darker bit here, which is going to be in black, okay, highlighted, well, grey, sorry. It's going to be in grey here, okay. It's going to be actually emails. So actually I could actually keep it the same, you know, I can actually keep that the same. And then obviously, yeah, I can actually keep it the same, to be honest with you. I didn't think I'd be able to keep it the same. So obviously you can see there then that the darker color here is obviously for emails, and then you've got the texts. So emails comes first, you know that's your bottom one, okay? So I'll just take my time to draw here. I'm joking, I'm not going to take ages making it perfect. Obviously, I'm just to illustrate, okay, what it is. You don't need to spend your whole time there in your exam drawing. I don't think they've made the GCSE exam maths papers that easy yet to just sit there and draw. But you get the idea. They're looking for you to be able to understand and interpret this data and then being able to plot it. And then obviously my lighter bit is here. Here. Yeah, okay, I'm not going to do it perfectly. I'm not going to sit there and make sure every single square is done. Okay, guys, so you obviously get the idea. You've been able to interpret the data and then be able to use this data to then plot it here, okay? So that's actually 2 marks for completing the chart there. So all you need to do is make sure that you added in this. And that's not a lot of marks to do all of that, okay? So just make sure you're doing each of the points, okay? Right, I'm going to go back to the other questions now. So question number 9B then says that in total, what fraction of the messages were emails? Give your answer in its simplest form. So here, okay, what I've got is first of all, I need to look at a total fraction. So it says what well, the fraction of messages were emails. So the fraction is going to be the emails, okay, over the total number of emails and texts put together. So what I'm going to first of all is work out emails and texts first of all. So the total number of the emails is going to be 12 plus 8 plus 10 plus 6 plus 12. Now, luckily, I'm a bit lazy. I've got a calculator with me. I'm going to make sure I use it. Okay, I'm going to make sure that I don't just let it sit there. So 12 plus 8 plus 10 plus 6 plus 12. And I'm sure you can all do this in your head, which is obviously 48. So you can all do it like that, which gives you 48. And then 5 plus 6 plus 3 plus 6 plus 4. I'm just going to do it in my head this time. That's obviously going to be 6. 24. So then what I need to do then is say I've got 48 emails, and 24 texts. So my fraction, okay, is going to be the number of the emails, which is 48, over the total messages altogether. So what that's actually going to be, it's going to be 24 plus 48, and that's going to give me an answer of 72. So my fraction is going to be 48 over 72. Hope that makes sense. What I'm doing, guys, I'm doing the emails, messages with emails, and I need to do that to a fraction over the total messages altogether, emails and texts. So I add up the total, and then I put 48 as it. And it says, give it in its simplest form. Well, what I can actually do is it's not cheating because it's a calculator paper, because I can do 48 over 72 into a calculator here using the fraction button. And actually, it gives me it as simplified already. So I can say 2/3 in its simplest form. Okay? 10 is perimeters. I'm going to hand back now over to Abdallah for this question number 10.
Okay, question number 10, guys. Each side of a square is made 3 times as long. What happens to the perimeter? Okay, so imagine I've got like a square here, guys. So just drawing this square. Okay, so let's say the length here, I'm going to call it x, okay, x and x. So for this like ordinary part. Now, adding this together, guys, so remember that the perimeter is the distance around the square. So it's x plus x plus x plus x. So the perimeter, so I'm going to call P is equal to 4x, okay? Now, let's say I wanted to draw like another square, guys, okay? So it's going to be obviously a bit bigger this time, okay? So this is my other square. And this time it's saying that the distance is 3 times bigger. So changing my color actually, so make it a bit clear. So this time I'm going to have a 3x here. So that should be a 3, guys. Sorry if it's not very clear. That's a 3x, not a 7. Sorry. Should be a 3x there. Okay, so drawing it properly, that's 3x. Okay, this is going to be 3x. This is going to be 3x. Okay, and this is going to be 3x. Because in algebra or in maths, when it says 3 times as long, well, if that is x here, 3 times as long for this one, it's going to be 3 times x, which is 3x. So adding this together, guys, 3x plus 3x plus 3x plus 3x is going to give me the perimeter is going to be equal to 12x. Now, comparing our first answer, so 4x to 12x, what have I done to get from 4 to 12? Well, I've times it by 3. So I'm going to circle option 1. So just to be clear, 4x times 3x gives me the 12x. So making everything 3 times as long makes my perimeter 3 times as big as the original amount, if that makes sense. Okay, question number 11, guys. We are given the list of ingredients needed to make 6 pancakes. We've got flour, eggs, and milk. Okay, so 6 pancakes. Complete the list of ingredients to make 9 pancakes. Well, what I can do, guys, is work out the number of the number of grams and amount of eggs and milk for 3 pancakes by halving my answer. So 3 pancakes, guys. Okay, if I can write it properly. Sorry. That is my poor handwriting, actually. So 3 pancakes, okay. So a half of 120 is going to be 60. A half of 2 is 1, and a half of 210, so is going to be 105, guys. Okay. So checking my answer here actually on the calculator. So 210 divided by 2 is equal to 105. And then checking the next one, 2 divided by 2 is going to be 1. Okay, so doing that on the calculator. And then lastly, for the number of grams of flour, 120 divided by 2 is 60, guys. Okay, what I can now do is, so for 9 pancakes, well, I've got the ingredients for 6 pancakes plus 3 pancakes. So what I'm going to do is I'm going to do 120 plus 60. So let's just work this out here, actually, or we do it on a calculator. Actually, it might be quicker. You know, I calculate 120 plus 60 gives us 180. So we're going to have 180 grams of flour. So make sure that you that you put the grams at the end. Okay, so it's not been filled out. So 180 grams. The next part is going to be 2 plus 1. Obviously, checking that on the calculator. Okay, we're going to get the answer of 3. So we're going to have 3 eggs. And then lastly, for milk, we're going to have 210 plus 105, guys, which should give us 315 milliliters. So make sure that you put in your correct units. So I'm going to just put ml there for milliliters. And that is my answer for question 11A, guys. Right, guys, part B. So it says we've got to convert 210 milliliters into fluid ounces. 1 fluid ounce is 28.4 milliliters. Now, writing this way, so I've got 28.4 milliliters equals 1 fluid ounce. So 1 fluid ounce, so 1 FO, I'm going to call it, okay, for short. Okay, so we want to work out 210 milliliters of 2 fluid ounce. Now I've got to work out a multiplier. Now I've got to do 210 divided by 28.4 on my calculator. So working this out on my calculator, okay, it is going to give me the multiplier. Okay, so working this out, guys, okay, when we press equals, so we're going to be timesing by 7.394366197. Now, the key bit here, guys, is please don't round your answer just yet. So round your answer right at the end. Okay, so for this part, I'm going to multiply this by the same scale factor. So I'm going to multiply 1 by that number. So multiplying anything by 1 doesn't actually change my answer. So this is the multiplier again. So writing it out in full, just so we're happy. Okay, so when I multiply 7.394366197 by 1, I'm going to get the same answer. So 7.39 I'm going to put here, rounding that to 1 decimal place. Well, the 9 bumps up, so the answer is going to be 7.4 fluid ounces. Question number 12 is asking us to reflect shape A in the x-axis. So this is what I call, guys, so this line here where it has the x little point, that is the x-axis. So that is the line for the x-axis, guys. So what I want to do is reflect it. So the way that I've actually learned it before, guys, is I'm going to count the number of squares from each of these points to the x-axis. So it is going 1 point there, so I'm going to go 1 point down. So I'm going to put like a dot there or a cross. It's going 1 point down to the x-axis, so going 1 point down again. The last point is 1, 2, 3, 4. There's going to be 1, 2, 3, 4 squares. So that is going to be my 3 dots, and then join the lines on for them. So the line's going to go all the way down. Go all the way across, okay, and then it's going to look like that. So that is the reflection of shape A in the x-axis. Remember that this line is the x-axis. That's my x-axis, and then yeah, that is my y-axis. Okay, so when it has the letter y, then that's my y-axis, and that's my x-axis. Okay, so that is reflection, guys.
I'm going to move on to question number 13, which is quite a long question. It is a 6-marker question, so it's looking for probably about 6, roughly around that, okay, for you to get you the full mark. So you've got a charity sends an appeal to 3,000 people. The letter asks for a donation of money. Now, here is some information about the last appeal letter that the charity sent out. So they sent out this last appeal letter, and this is the sort of, analytics that came back. So they got a half of the people who sent the letter made a donation. So we know that half of 3,000 people were making a donation. We'll have a look at that in a minute. The average donation of those half of that 3,000 people was about £8.60. And 1/3 of the people who made a donation filled in a tax form. Now, if you fill in that tax form, the government adds a 25% to the donations of these people. Okay, so we're going to be looking at how much that is. So the question actually asked for 13A says, using this information, work out the amount the charity can expect to receive from this appeal. So this is quite, average, because obviously it's average donation, all of that, and all of those sort of things. So we're going to apply this all together, and it's 6 marks, like I've already said. So going back, first of all, we're going to look at how many people donated together. That's the first thing we need to look at. It says that half of the people who were, half of the people who were, so having a look at this information, first of all, we want to work out how many donations there were, because that's what we're looking at. How many people actually donated, first of all. So it says here, half of the people who were sent the letter made a donation. So half of those people. Now, how many people were sent the letter? 3,000 people. So if we just go back to my workings and say the number of donations here, we can work out the number of donations, because what we've got is we've got 3,000 people who sent a letter, and half of them were sent it. Half of them, not sent it. Half of them paid a donation. So what we can do is do this on our calculator in our head. We know it's going to be 1,500, but 3,000, okay, times by 1/2 gives me 1,500. So my total number of donations was 1,500. So 1,500 people actually donated. Okay, so that's my first bit done. I've worked out the number of donations that people actually did. Now the average donation was £8.60. Sorry, so the average donation was £8.60. So if we know on average that it was £8.60, to work out the total donations that we've got in money, we can do that. The average was £8.60, and 1,500 people paid £8.60. So you're actually need to times those together, because what you've got is you've got the 1,000 people. So these are the number of people, and this is how much they pay on average. So if you times the number of people that you've got paying times by the average amount that they're paying, will give you the total donation that you got. So again, on a calculator doing that, 1,500, I can just leave my same answer, times by £8.60. I actually get 12900. So that's 12,000. Oh, sorry guys, that's actually 12,900. Okay. So then what we've got is we've worked out that part as well now. So that's now done. Now we've got the 1/3 part. So we've got that 1/3 of the people. So we've now got the 1/3 of the people, okay, who made a donation filled in a tax form. The government adds a 25% to donation to these people. So what we're now working at is 1/3 of the people who made a donation. So 1/3 of the people that made a donation of the donations is not 1/3 of 3,000. It's 1/3 of 1,500, because they're the people that made donation. So 1,500 times by 1/3. Again, you can do in a calculator. So 1,500, just to clear that. So 1,500 times by 1/3, or I could just divide that by 3 and then times it by 1. It's 500. So 500 people actually filled in a tax form. Okay, so the tax form was filled by 500 people. Now, 25%, it says that 25% to the donation to these people, it gives them 25% to these people. So it's actually going to be 25% of £8.60, because it's 25% of that money being added to them. And that's going to be times by 0.25. So 25% of £8.60 is 8.60 times by 0.25. So 25% of that, it's obviously doing 8.60 times by 0.25 will give you that. So £8.60 times by 0.25 gives you that, because that's our multiplier, and that's £2.15. So we know that they get £2.15. Okay, we get a £2.15 donation to these people. So they get £2.15 added to it. So what we've then got is our tax added, okay, to work out how much it is. The tax added is going to be the 500 people that done it times by 2.15, because that is how much extra that they're being added on. So if you're doing 500 times by 2.15, okay, that is how much is being added on to that with the 25% adding on. So 25% added on to 500 people. Hopefully this is making sense. So 500 times by 2.15, 500, and just times that by 500, is 1,075. So 1,075 are the number of people that actually got added that onto. No, that's the tax added onto the 500 people. So then the total, okay, that they can expect to receive is going to be the 12,900. It's going to be the total donations. Please do not add up this 1,500. It's the total donations plus, okay, plus it's going to be added on to the tax added, okay, because remember, we want to do that and have a look at the tax added. So the government adds 1,075. So adding that onto 1,075, that's 5, 7, 9. 2 plus 1 is 3. So that's 13,975. Hopefully that makes sense, guys. It's quite a long question, okay? It's about 6 marks, okay? So having those points in. But remember, what I've done is I've gone through each of these. I've worked out that, I've worked out that, and I've worked out that. And what I'm then doing is I'm adding that 25% onto the 500 people that actually filled out a tax form, and then adding it onto the total donations to find a total that they can expect to receive. Okay, so I hope that makes sense. Okay, 13B though says that the average donation from the people who filled in a tax form was more than £8.60. How does this affect your answer to part A? Well, firstly, what we've got is we've got that actually we worked out that before originally that the average donation was £8.60, and that was for it, and it was 1/3 of the people who made a donation. So if they're being about £8.60 for 1/3 of the people, okay, filled it out, we know that that is actually going to be 500 people. We know that the 500 people done it. So if we then done 500 as my answer, I've then done 25% of 860 times by 0.25, and then I've done 500 times by 2.15. Well, if it was more than that, then my actual increase is going to be bigger, isn't it? Sorry, let me just show you. This number here, the 25%, well, the £8.60 times by that, well, if it was more than £8.60 times than that, is going to make this bigger. So then when I do my tax added, which we now think is 500 times by 2.15, well, actually, the amount of donations where the extra 25% tax is added, if you increase that, because actually you're times it by more than £8.60, so this 2.15 would be bigger, your actual final answer would be bigger. So your final answer would be increased. Hopefully this is making sense, guys. So actually it would be higher. And my reason for that is the amount of donations. So the amount of donations, you know, where we added on the 25%, the amount of donations where the extra 25% tax is added. Well, if we're adding on now we're adding on bigger extra because it's more than £8.60, the 25% that the government add is going to be more. So actually it's been increased. So actually it's going to be a final answer being bigger. So I hope that makes sense. I'll just say it again. If you're adding on more, your tax, you're paying more donation, then when the government add on 25%, 25% of that number is going to be more. Okay. So then actually your final answer would actually be bigger. Okay. I hope that makes sense. Now I'm going to hand back over to Abdallah for question number 14.
Question number 14. Lee wants to draw the graph y equals x for the values of x from -5 to 5. Here is his graph. Okay, so this is the graph here. Make two different criticisms of his graph. Well, the first one is it's saying from -5 to 5, but Lee's gone from -4 to 4. So Lee hasn't done the full range. So Lee hasn't done the full range of x values. Of x values, guys. Okay, so that's the first part there. Okay, so that's my answer for the first one, guys. For the criticism number 2, guys, well, we can see that the line y equals x here. So for each x coordinate, the y coordinate is going to be the same. So here, when x is -1, y should be -1 actually. So the graph should be coming down here. Okay, so the coordinates are incorrect for when the values of x is less than 0, if that makes sense. So let's just be clear what I mean. So let's just draw the line. Okay, so when the values of x is less than 0, so when y equals x, guys, so the x coordinate should always be equal to the y coordinate. So when x is -1, y should be -1 actually, not +1 actually. So that is the answer for the first part. For the second part, sorry. When x is -2, y should be -2. Okay, so the values have been plotted incorrectly for when the values of x is less than 0. Okay, if that makes sense. So number 2, what I'm going to write is the value of x. So, or the value, sorry. So the values of x of when x is less than 0 is plotted incorrectly. Plotted incorrectly, guys. Correct. Okay, so that's my answer for the second one. Okay, so the values of x is plotted incorrectly for when x is less than 0. So they are my 2 criticisms, guys. Okay, so I hope that made sense. Right, question 15, guys. A company uses the formula, so this formula to work out the cost in pounds. Okay, so the total cost £8 of a taxi ride. £4 is a fixed charge. Okay, so that's my fixed charge. M is the number of miles traveled, so M is the number of miles. And B is the charge of booking online. So this plus B is booking online. Now it says, so part A says, Claire books a taxi online, okay, and travels 8 miles. She pays £20 altogether. What is the charge for online booking? Now, £20 is equal to A. So subbing that into the formula, 20 is equal to 4 plus 1.8 times 8, because she travels 8 miles, so M equals 8 at this point, plus B. So working this out, guys, okay, so just being careful. So 4 plus 1.8 times 8, okay, gives us the answer of 18.4. Okay, so 18.4 plus B equals 20. Okay, so rearranging to make B the subject, I'm going to subtract 18.4 on both sides. So doing this on my calculator, I'm going to get the booking cost, okay, the booking cost is equal to 1.6 or £1.60, guys. So just be careful. So £1.60, okay, or 160 pence, okay. So that is my answer for part A. For part B, it says a different company has a fixed charge of £3, charges 1.9 per mile, and has no charge for booking online. Write a formula for the cost of C of a taxi ride for this company. Now, so the total cost, guys, so the pounds, okay, so the total cost, guys, is going to be equal to a fixed charge, which is 3. So 3 plus 1.90 times M, where M is the number of miles, okay, and there is no booking fee, there is no charge for booking online actually, so nothing has to come at the end now. So that is the formula. So it's 3 plus 1.90 M, okay, is the total cost for a taxi journey. Yeah.
Thank you, Abdallah. I'm going to now take over now for the next 3 questions. So question number 16 is probability. So what does A intersect B represent in probability of A intersect B? Circle your answer. Well, I've just told you the answer there by saying it. We need to first of all be able to understand what this little upside down U means. Well, the upside down U means what we call the intersection. And so what I'm going to do is I'm going to actually just show you what I mean by when I say the intersection. So if I've got 2 circles, and I've got a Venn diagram, okay, when I've got A equal to B, it means that the set of them, okay, it means this part here is the intersection. So hopefully, if we was to say A and B, we call this A, call this B, we will understand that the intersection here, let's say this is like people who like, no, let's say that these are some numbers. This is like prime and then them odd and then prime and B, you know, or anything like that, okay, or odd. Anyway, you get the idea. And it was in here. What this means is this means it's in both. Okay, so it means it's in both of them, the intersection part. So that little upside down circle means the intersection. So it means that middle part there. So hopefully you understand that that means in both of them. So it means the intersection. So actually, when you're looking at your answers, A or B or both, well, it can't be. It has to be both. So it can't be that one. A but not B. Well, no, it can't be that one. Not A and not B. Well, it can't be that one because it's got to be both of them. So A and B is your correct answer to that one. So I hope that makes sense. You need to understand that that upside down U, if you need to write that down, it's very important. The upside down U means intersection, okay, of the Venn diagram. Number 17 then says that a circle has circumference C and diameter D. C is equal to KD. What value does the constant K represent? Well, first of all, we need to understand what the circumference of the circle is. Now, circumference of the circle is normally pi D, or pi times by the diameter. So if you've got C is equal to KD, well, that's trying to say C is equal to pi times by D. So that's just basic knowledge of understanding formulas. So K constant is trying to represent pi. So C is equal to pi D. Okay, so that's trying to represent the pi. Okay, that constant K. Number 18 then, it says there are 240 cows on a farm. On the farm, number of bulls to number of cows is 1 to 30. How many bulls are there? It's a very simple ratio here with about an estimation. So what you've got is you've got 1 to 30 as your actual ratio. And now you know that there are 240 cows. So 240 cows is how many cows we've got when you've got them from there. So what you need to work out is what you've had to do is 30 to 240. So what I can actually do is in my calculator, if I do 240 divided by 30, it will give me what I've actually had to do to get to 30 to 240. So I've actually had to times by 8. So I also have to times by 8 on this side. Now, remember, this is the number of bulls. So this is bulls to cows. So we've had to go times by 8. So we have to times this by 8 as well. That means it's 8 to 240. So that means actually there's only 8 bulls. So the number of bulls on the farm is 8 to 240 cows. No, yes, to 240 cows. Okay. 18b then says that assume that 240 produce milk for 10 months each year. Each cow produces an average of 25 litres of milk per day. Estimate the total milk production in litres of the 240 cows in 1 year. You must show your workings. Okay, so a little bit of a worded question here, but actually it's quite simple. So we're going to assume that there's 30 days in 1 month. So writing this down to my examiner shows that I'm assuming that, because if some of them's 31, there's sometimes, you know, different number of days in each month, okay, depending on the month, okay, and stuff like that. So assuming 30 days, writing that down obviously shows the examiner that that is what you're going along, and that is why it's an estimate, and that's why it says assume. So if we're assuming that, then the production of that then is going to be that each cow produces an average of 25 litres of milk per day. So that's going to be 25 times by 30 days in each month. And it also says that they do that for 10 months per year. So the 25 times by the 30 is the litres of milk per day times by the number of days they do in 1 month, and then times it by 10 because they do 10 months. So in my calculator, 25 times by 30 times by 10 gives me an answer of 25 times by 30 times by 10 gives me an answer of 7,500. So 7,500 is how much milk production produces per day and 10 months, okay, on 240 cows. But that there is 7,500 litres. But that is for 1 cow, okay? Remember, that is for 1 cow because I've done it by 25 litres of milk per day. That's 25 litres of milk per day. And actually, 25 litres per milk per day. Well, if I was reading, okay, the question here, okay, have a look at the question that I've just read to you. Each cow produces an average 25 litres. So it's not 240 cows produces an average of 25. 1 cow, each cow, so each cow does it. So 1 cow produces 25 litres. So if you know what that is for 1 cow, we just need to times that. So the total for 240 cows, okay, is equal to 7,500 times by, because 7,500 litres is 1 cow, times by 240 cows, which we're trying to work out. In my calculator, I can just keep that same answer. Times 240 is 18 and then 50. So 18. Oh, So that is 1/8 and then 5 zeros. So 1/8, then 1, 2, 3, 4, 5. So there and there. So that's 1,800,000 liters. That is quite a bit of milk. Got to be honest. That's quite a lot of milk. Okay, so 4 marks, making sure that what we do is we follow each of those steps. Hopefully that makes sense. I'll hand back over to Abdallah for question number 19.
Okay, so question 19, guys. Here is a right angled triangle, 7.2, 9.6, and x. Should the x equals 12? Well, a right angled triangle, guys, means that we're going to use Pythagoras Theorem, and that states that a squared plus b squared equals c squared, where a and b are your two shorter lengths. So that's a and that's b and that's c. It doesn't really matter which one a and b are because they will always be the shorter sides. And the longest length has a special name actually, which is called the hypotenuse. So in mathematics, the longest side of a right angled triangle is called a hypotenuse. Okay, so hypotenuse. Okay, so that's the longest side, guys. So subbing this into my formula, I'm going to have 7.2 squared plus 9.6 squared is equal to x squared. Okay, so working this out, guys. So I'm going to use a calculator for this part here. So I'm going to work out what 7.2 squared is plus 9.6 squared on my calculator. Okay, that's going to give me 144. Okay, is equal to x squared, guys. Right, guys. So x squared equals that. So the opposite of squaring is square root, guys. So square root of 144 is equal to x. Okay, so typing that into your calculator, guys, 144 is a square number, so x is equal to 12. Now, there is one key point here, guys, actually, and it's actually quite important, actually. So solving x squared, actually, will always give us two solutions, but we're looking at a length, so x has to be a positive value. When I square root this, it's essentially plus and minus that. Okay, so the answer is actually plus and minus 12, but we are looking at the positive value because we're looking at length. So the length of that is going to be 12, okay, so 12 centimeters. So showing that, okay, as shown. So that's my answer for this question. Okay, question number 20, guys. Work out the values of a and b in this identity. 5 brackets 7x plus 8 brackets closed plus 3 brackets 2x plus b brackets closed is equivalent. So it's got 3 lines there. So it's the same as ax plus 13. Now expanding my bracket, so 5 times 7x is 35x, and 5 times positive 8, okay, is going to be positive 40. So expanding the brackets on the left-hand side, and then I'm going to have plus 3 times 2x, which is going to be positive 6x, and then I'm going to have positive 3 times b, which is going to be equal to 3b. And that's equivalent, so that's the same as ax plus 13. Okay, so I hope that you guys are with me so far. Okay, that should be a plus there, so plus 13. Okay, so now, guys, so changing my color actually, so now collecting the like terms, so 35x plus 6x is equal to 8x. So ax, okay, so 35 plus 6x, that's the same as 8x. Okay, so it's equal to 8x. 35 plus 6 is 41. So 41x is equivalent to 8x. So comparing the coefficient of x, so comparing the number in front of the x, we know that a is going to be equal to 41. Okay, so nice and easy there. Okay, I hope it actually makes sense. So it's collecting the like terms. Right, the next one, guys. So looking at the numbers, plus 40 plus 3b has to equal 13. Okay, so 40 plus 3b, so that has to be equivalent, the same as, so it has to be the same as 13. Okay, so what I'm going to do is treat this as like an equation. So I'm going to subtract 40 on both sides. Okay, so I'm going to have 3b, okay, is the same as, okay, negative 27. So 13 minus 40, okay, is negative 27. Okay, 3b means 3 times b. So dividing both sides by 3 means that b is equivalent to 9. Okay, so b is equal to minus 9. So a is 41 and b is minus 9. So this question is about expanding your brackets and also comparing coefficients. And what I mean by that is so like collecting like terms. So here I've got 35x and 6x. That's going to be equal to something x. So we know that 35x plus 6x is 41x. So therefore a has to equal 41 by definition. And comparing the constants, okay, so 40 plus 3b has to be equivalent to 13. So what I've done is treat it like an equation. So minus 40 on both sides, and then dividing both sides by 3 means that b is equal to 9. Okay, and then what I can do is sub these back in, and it will show me that the left-hand side equals the right-hand side, okay, as shown. The first 4 terms of a linear sequence are 7, 11, 15, and 19. Circle the expression for the nth term. So it is working out a general formula for this sequence. Right, guys, so work out, first of all, the common difference. So 7 add something is 11. So 7 add 4, guys, equals 11. 11 add 4 is 15. And 15 add 4 is 19. Okay, so it's adding 4 each time. Now, adding 4 each time, guys, is essentially following the 4 times table. So adding 4 each time actually can be written as 4n. Now, 4n is my 4 times table. So I've got 4, 8, 12, 16, okay? And then this sequence here, okay, is 7, 11, 15, and 19. Now we know it's going to follow like a 4 times table, but there is going to be one slight difference here. So 4 to 7, I'm going to have added 3. Okay, so 4 add 3 is 7, 8 add 3 is 11. Okay, working our way down. 12 add 3 is 15, and 16 add 3 is 19. Okay, so the final part here is going to be add 3. Okay, so I'm going to circle this option here. So that is working out the nth term of a linear sequence, guys.
Okay. Also, I just want to share with you guys as well. So Abdallah there showed a really good method, a really good way, and that shows really how nth term works and the reason why it works. Okay, so a lot of people will do this easy way, which I'm going to show you now, is that exactly the same as Abdallah. Work out what it goes up by, which it goes up by 4. And then if you take away 4 from the first term to see what actually you were at before, 7 take away 4 is 3. So what you can do then is say, well, you've got plus 4n, and then there's a positive 3 there. So it's 4n plus 3, just like Abdallah said there. But that one here is a really good way. And this bit here, I've just actually put in a circle, actually is the proof of nth term and actually why nth term works and what is nth term, okay? So I thought I'd just add that in there as well. Okay, so question number 22 then is about estimating means. And it's here is some information about 20 trains leaving a station. It says that we've got is work out an estimate of the mean number of minutes late. So we've already been indicated that we need to work out the midpoint so far. So what I'm actually going to do is the midpoint is these two added up together and then divided by 2. Well, 5 plus 0, well, what's half of 5? That's 2.5. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, divide that by 2 is 12.5. And then 0, we don't really need to work with this one because it's 0 number of trains. So this column here, we're actually going to call X, and we're going to call this the frequency column. Now, this is what we call fx, and f is the frequency times by x, whatever x is. And in this particular case, x is the midpoint. So what you're going to do is you're going to times all of these together by giving you an fx, which is your frequency times by the midpoint. So 12 times by 2.5, I'm going to do this all in my calculator. So 12 times by 2.5 is actually 30. Oh, so 12 times by 2.5 is actually 30. 7 times by 7.5. Yeah, guys, it's actually going to be 52.5. And then 1 times by 12.5, we know that's just 12.5. So to get an average mean, which is the mean, which is the total divided by the the numbers added together by divided by how many you've got. So the estimated mean is going to be the sum, not estimated men, estimated mean, if I can actually write. Estimated mean is going to be fx, the total sum of fx, which is this column here, divided by the total frequency we've got. So adding up the total fx here, okay, which is 30 plus 52.5 plus 12.25. Well, if I just do that on my calculator, so 52.5, I can just do it from here, 12.5 plus 30 gives me an answer of 95. So my total is equal to 95. So my total fx is equal to 95 over the total frequency. So the total frequency is the number that we've actually got. So that is the total number of trains. Because remember, mean, so if I had like 1 plus 2 plus 3, if I wanted to work out, I had a sequence of 1, 2, 3, and I wanted to work out the mean of it, you add up how many you've got. So that would be 6, and you divide by the number you've got. So I've got 3 numbers, so 6 divided by 3, okay? So that would be how you work out mean. So the number that we've got, we've worked out the total, okay, frequency, but we need to divide it by we've worked out the total of fx, sorry, but we need to work out the total frequency, so the number of trains. So don't add up the number of midpoint. Don't ever do the midpoint. The midpoint is to work out the frequency. So the number of trains. Now, we don't need to add that up because it's already told us nicely it's 20 trains. So 95 divided by 20. So we can do that again on our calculator. 95 over 20. 95 over 20, like that, which gives me an answer of 4.75. So 4.75 is the number of minutes that are late, okay? So the estimated number of minutes late is 4.75. Hope that makes sense, guys. 22B then says the station manager looks at the information in more detail. So you've got, again, the number of minutes late, but my differences here are a little bit different. And actually, I've got more data. It says he works out an estimate of the mean using the information. How does his estimate compare with the answer to part A? Tick one box. So what we've actually got here, if I was to pretend that I've got another midpoint here, so if I was to pretend that I've got another midpoint here, and I've got an fx here, I'm just going to put m for midpoint and fx here. Well, what I've got here is the midpoint is 1, and that's going to be 12. Well, here, that's going to be 3, 0. Here, that's going to be 5 and 35. You can see what I'm doing, obviously. I'm working out the midpoint and the fx. That's going to be 7. That's going to be 0. And that's going to be 9. That's going to be 0. That's going to be 11. That's going to be 11. So what you could do, actually, is work out the total mean here and see what it would do. And it would give you a lower than part A. It would give you a different answer. It would give you a lower partner. If you actually did that, it would be 29. Okay, so give you a lower one. But what you could also do is look at this. So my numbers of 0 to 2. Well, actually, the minutes late here, if I compare it here, well, comparing here of 0 to 2, well, actually, I've got 12 times by 1, which is 12. So I've only got 1 as the midpoint here. So I'm saying that the number of minutes late for the number of trains is 12. So 12 trains were 1 minute late. Now, the number of trains that were 1 minute late here, okay, was 0 to 5. So my difference here, my actual difference is less, okay? So because it's saying that only 1 minute late is 12 trains. But it's saying here that 12 trains, okay, are actually 2.5 minutes late. The 2 to the 4, no, sorry, the 4 to the 6, well, that's the 0, so we don't need to worry about that. The 4 to the 6, well, 5. It's now saying that 5, okay, 7 trains are 5 minutes late. Well, last time it was saying that it was included in the 12 trains. So now we've got less than, because it's now saying that we've got 5 that are 7 minutes late. Okay, it would actually be here, it'd be 5 minutes late, so it'd be here. So it said the number of trains is 7. So this time it's saying that the number of trains, okay, is 7. So we've actually kept that the same, to be honest. And then obviously the 10 to the 12, well, that's 11 times by 1, which is 11. So 11 trains are being, so 1 train has been 11 minutes late. Well, 11 minutes late here, okay, it's saying here that actually 10 to 15, well, my difference here is 10 to 12. So that difference is 11. So actually, I can't text here because this is to less than 15. So my difference here is actually less than. So my numbers of minutes late is actually shorter. So it's going to be lower than part A. So hopefully that makes sense. I know it's a little bit hard to understand, but hopefully that actually makes sense, that question. Back over to Abdallah for question number 23 now.
Okay, question 23, guys. So 2 identical quarter circles are cut out from a rectangle as shown. Work out the shaded area. Okay, so the first part, what I'm going to do is work out the area of the rectangle. Okay. Right, guys. So I know that that full distance there is 12. Therefore, okay, this distance here, the full distance here is going to be 12. Okay, so therefore that implies that each of these distances here, so using like a different color, okay, so halfway there, that's going to be 6, and then the other line is going to be 6. Okay, so it's half of 12, which is 6. Okay, so that's going to imply that my radius, which will come on the sheet, so the radius of the circle is going to be 6, guys. So this distance here is going to be 6 centimeters. Okay, and then this one here is also 6. Okay, and then this part here, guys, so to be clear, actually, so this part here is 6, and this part here is 6, guys, just to be clear. So the area of my rectangle, well, the formula is length times width. So the area of the rectangle is going to be 12 times 6, okay, which is 72, guys, okay? So checking that on our calculator, okay, so 2 times 6 is 12, and then 10 times 6 is 60. 60 add 12 is 72. So 72 centimeters squared. So that's the area for the rectangle. Okay, I'm now going to work out the area of the quarter circles. Okay, so the area for a circle, so the normal area, so area of a circle, normal, okay, is pi r squared. Okay, so that is a formula that you will have to remember. So it's pi times r squared. Okay.
How about area to me?
So that is going to be the area of a full circle. Now we have got a quarter circle, so we're going to divide our answer by 4 for the quarter circle. So it's going to be pi times r squared over 4. Okay, so that's going to work out. I'm going to call this C1 for circle 1 and C2 for circle 2, although it's going to give me the same answer because it's both quarter circles. So the radius, guys, we said from the first part is equal to 6. So substituting in 6 into my formula, I'm going to have the area of C1. So area of C1, guys, okay, is going to be pi times 6 squared over 4. Okay, so pi times 6 squared over 4. 6 squared is 36, guys. Divided by 4 is going to be 9. So it's going to be 9 pi centimeters squared. So checking this on our calculator, guys. So make sure that we're checking the answer on the calculator. So pi times 6 squared, and then divide the answer by 4. So divide the answer by 4 is equal to 9 pi. Now, we will leave our answer in this form for now before we obviously convert our answer. So 9 pi means 9 times pi. Pi is just a constant. So pi is approximately 3.14, and it goes on, okay, forever. Okay, so pi is approximately that on our calculator. Right, the area of C2, guys, is going to be the same as the area of C1. So the area of C2, okay, is also going to be 9 pi centimeters squared. Okay, so I hope that actually makes sense so far. So the total area of the 2 quarter circles on my calculator is going to be 9 pi plus 9 pi. So 9 pi plus 9 pi, we should be happy that that's going to give us 18 pi. Okay, so 18 pi centimeters squared for the areas of both of these quarter circles. So to be clear, actually, so okay, 18 pi centimeters squared. Now, our last step, guys, is to do 72 subtract 18 pi, because that is going to give us the shaded area. So doing this on our calculator, 72 subtract 18 pi, okay, is going to give us an answer of 15.45, okay, centimeters squared to 2 decimal places, because the 1 on our calculator rounds the number down. Okay, so it's 15.45 0.545 centimeters squared, guys, for the area of the shaded region. Okay, so that's my answer for that. So make sure that you're happy with knowing the areas for area of a rectangle and areas of a circle. Remember that the word quarter means that I'm dividing my answer by 4. Okay, so the area of C1 is a quarter pi squared, and the area of C2 is a quarter pi squared. Actually adding it together and then taking it away from the total area gives us this final answer. So I hope that made sense, guys.
That's a really nice question. Well done, Abdallah. Really nicely explained. So question number 24 then. Okay, so this is quite, again, another question, okay? 4 marks, okay? And it's to talk about proportion. So you've got the diagram to show the position at a tap when off and fully on. So you've got off, which is just like that, and then fully on is at 180 degrees. Now, when fully on, water flows out at the tap at 14 litres per minute. So that's quite important. We need to remember. It flows at 14 litres per minute. The rate at which water flows out is in direct proportion to the angle of turn. The tap is turned 135 degrees. The water flows into a tank with a capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? You must show your workings. So first of all, we need to know what actually this means here. So you've got that it works. So first of all, we need to know what it is actually saying. It says the rate at which water flows out is in direct proportion to the angle of turn. So what we can say is we can say that F is the flow of water, is in direct proportion, which is little fishy, okay, in direct proportion to the angle of turn, so we're going to call turn, which is T. Now, when we're looking at direct proportion, we're looking at proportion, okay, that's F is equal to, we can say that the proportion is equal to, and then we can say that our K, which is constant, times by T. So then rearranging well, adding in our formula, well, we know our flow is 14. So when the flow is 14 litres, we know that it is K times by 135 degrees because the T is for angle of turn and then K is our constant. So then when T is equal to 40, when T is equal to 180 degrees, when it is at a full turn and it is turned on all the way, fully on 180 degrees, the F is equal to 14 litres per minute, okay? It comes out at 14 litres per minute. So what we can do here is rearrange our equation and say, well, when F is equal to 14, that is equal to K times by 180. So rearranging that equation to then solve for K, we can do 14, okay, is equal, 14 over 180 is equal to K. So in our calculator, doing 14 over 180, see if that simplifies down. That simplifies down to 790. So 790, okay, is equal to K. So when you've got F is equal, so I'm just going to follow my results here. So F is equal to 7T, okay, over 90. Now 7, remember, is this bit here, which is the T part for the turn, because we've just worked that out, over 90, which is it. So when T is equal to 135, and F is equal to 7 times by 135, because the flow is equal to 7, okay, which is 7 from the actual workings out that I've just done there, times by 135, which is turned on at 135 degrees here. You can have a look at that, okay, over 90, which I've got from working out it as 180, which one working out is K. So over 90, hopefully that makes sense, guys, okay. So 7 over 9, so I'm actually going to do now that when it's like that, 7 and 125 over 90 gives me an answer of 10.5. Now, 10.5 is the number of litres per minute. So we've just worked out how many litres per minute it does when you've got a flow of 7 times 135 over 90. So what we can then do is if we know that it does 10.5 litres per minute when it's at 135 degrees, it has to fill up 79.8 litres. So doing 79.8 litres, because it's got to do 10.5 per minute, it will tell me how many minutes it's going to take. So 79.8 is what I've got to fill up, and it does it in 10.5 litres per minute. So 79.8 litres divided by how many it's doing per minute, it's doing 10.5 per minute, it takes 7.6. So no, it doesn't take less than it. So no, it takes longer than 7.5. Now, even though it's only a little bit longer, it still takes longer because it's asking you, will it take less than? And no, it doesn't. It takes longer. Okay. So I know this isn't in a very nice order. I haven't got much room, but the examiner, I'm just going to put this in a little box. The examiner will find my final answer to be that. So I hope that makes sense. So if you didn't understand that though, have a look at some questions and some videos on direct proportionality. Okay. They're actually quite easy once you understand the hang of it and you understand what that actually means. So what you could do is, you don't understand it, look at some questions and look at some videos on direct proportion, and then come back to this question. It will make perfect sense. Okay. 500 over to Abdallah.
Okay, so this triangle is equilateral. Okay, so that's a very important part. Is the perimeter of the triangle greater than 1 meter? You must show you're working. Now, equilateral means that all these side lengths and angles are going to be equal. Okay, so this length here equals this length here, which equals this length here. Okay, so what I'm going to say is, I'm going to set 6x subtract 10 equal to 4x plus 5. Now, it doesn't actually matter which two equations that you put equal to each other. So this can be equal to this, or this can be equal to this, or this can be equal to this, as long as two of them are equal to each other, actually. Okay, so what I've done is pick like an easier equation to solve. So solving this guy, so subtracting 4x on both sides, 6x subtract 4x is going to be 2x. 2x minus 10 is equal to positive 5. Okay, adding 10 to both sides, I'm going to get 2x is equal to 15. Okay, so 2x equals 15, so 2 times x equals 15. Therefore, x is going to equal 15 over 2, guys. So dividing both sides by 2, I'm going to get x is equal to 15 over 2, which is equal to 7.5 centimeters, guys. Okay, so that is the value for x. I can now substitute in the value for x into either one of these, and I have to show or find out whether or not that the perimeter is greater than 1 meter. So remember that perimeter is the distance around this whole shape, guys. Okay, so I've got to substitute in 7.5 into these three expressions. So subbing it into this one here, so x is 7.5. So the value of my expression for 10 lots of that is going to be 10 brackets 7.5 subtract 4. So that's going to be 10 lots of 3.5, which is going to be 35. So this length here is going to be 35 centimeters. So hopefully that you're with me so far. So this length here is going to be 35. Okay, and we can check it on our calculator. Okay, so 10 lots of 3.5, which is that. Okay, I'm now going to sub in x is 7.5 into 4x plus 5. So I'm going to have 4 times 7.5 plus 5. So I believe the answer is going to be 35. Yeah. So 35 centimeters. Okay. And I just realized actually, so like whilst doing this question actually, so the lengths are going to be the same actually. So I don't actually have to work out this last one because that's also going to be 35 actually. So I've just realized that once I know what one length is, then I can work out what the other three lengths are. So 35 add 35 add 35, work out the total perimeter. So the perimeter is going to be 35 times 3, which doing this on my calculator, okay, is going to give me 105. So it's 105 centimeters, which converting that to meters, I'm going to divide it by 100. So dividing it by 100, okay, so obviously being careful with our place values here. So dividing it by 100, sorry. Okay, I'm going to get 1.05. And that is greater. So it should be a 1 there, not a 2. So it should be 1.05, which is bigger than 1 meter. So therefore, the perimeter is bigger than 1 meter.
Question number 26 then says an approximation for the value of pi is given by 4 brackets 1 minus 22 over 57 plus 22 over 85 minus 22 over 105 plus 22 over 117 minus 22 over 242. use your calculator to show that this approximation is within 0.1 of 3.14. So like Abdallah was saying earlier on when we was looking at pi and stuff, that actually it's roughly around 3.014. So no, 3.14, which is correct. So if we would need to put this into our calculator, so I'm just going to be here, a little bit of an awkward silence for a minute whilst I put this in. So I don't want to muck anything up. So I've got 22 over 85 minus 22 over 105 plus 22, plus 22 over 117 minus, just making sure that you click that little arrow, minus 22 over 242. And I'm going to put the arrows again just to make sure I can get back out of my brackets. Just making sure, obviously, that I've got that exactly the same. 22 over 242, yes. 22 over 117, yes. Plus 2215, yeah. 22 over 15, then there should be a minus, yeah. Yeah, so that's exactly the same as mine. So if I click that answer, I get 3.014839619. So what I'm actually going to do is I'm going to write that at the full calculator display. So I'm going to say that's equal to 3.014839619. So then what I can do is I can say that it's within 0.1 of 3.14. Well, what I can do is I can do 3.14, take away 3.0148. Oh, that's not, that is an 8. 3.014839619. And then what that gives me is going to be in between those, so I can see if it's in that. So I can just click minus, so don't take it out. 3.14, it gives me an answer of minus, but obviously it's just I've done it the other way round because I've done 3.14 minus it. I should have done I've done 3.014839619 minus 3.14. It's going to give me a minus number, so just forget about the minus because I've written it as that way. So it's going to be 0. I'm not going to write out the whole thing, 0.09816, sorry. So I've just rounded that up to the nearest ones, okay? So 0.0986, and that is bigger. So I'm sorry, that is within 0.1. So 0.1 is bigger than that, okay? So it's within those of 0.1 of 3.14, because obviously that 0.9 would round that up to 0.1. So it's within 0.1 of 3.14. Okay, so I hope that makes sense for that question now. 27, which is actually the last question of the paper. You've got work out 9.12 times by 10 to the power of 10 over 3.2 times by 10 to the power of 4. Give your answer in standard form. So actually, this is a really simple question. Okay, so what you first of all need to realize is that if you've got the same base that you can just take away and you're dividing, you can take away the powers. So I've got 10 to the power of 10 divided by 10 to the power of 4. So now I can take these away. So that's 10 to the power of 6. My bottom number, it's going to be times by 10 to the power of 6, okay? So with standard form, it's always times by 10 to the power of something. And that can be either a minus or a positive. So mine's times by 10 to the power of 6, sorry, I couldn't speak that. And then what you've got to do is 9.12 divided by 3.2. So in my calculator, very simply, I can do that. 9.12 divided by 3.2 gives me an answer of 2.85. I can also do it in this way as well, just to show you. 9.12 over 3.2, which is 2.85 times, which is actually 2.85 times by 10 to the power of 6. So that is it in standard form, 2.85 times by 10 to the power of 6. And just to show you as well, if you've done it like, and let's say if you was to do it like this, okay, times by 10 to the power of 10 and times by 10 to the power of 4, okay, you're actually not going to get the right answer. So you can't just put that into your calculator and expect you to get the right answer, because your calculator and function to know that how that's worked. It would actually work that out and then divide it by it as well. Just some mathematics notes. These are what we call the exponents, and this is what we call the magnetizer. Okay, the mantiza. Okay, sorry, mantizer or mantiza. How you say it? So the fancy mathematical word. That's a bit of a nerdy mathematical word for mantiza. Okay, right. So that is actually the end of the paper. It's been an absolute pleasure going through these first two papers. We're going to go through paper 3 next as well. So Abdallah, it's been an absolute pleasure for having you on. Thank you ever so much.
Yep. Thank you as well, Cameron. So I really appreciate like collaborating with you and working with you with these papers. Yeah, it has been really good actually. So thank you for having me on again today. I really appreciate it, and thank you guys for watching the video. Like I said at the start, if you found this video useful or informative, please drop it a like. Please subscribe to the channel, and also please press the bell icon so you don't miss out on further uploads. For these videos. Okay, so thank you so much for watching, guys. I really appreciate it. And thank you as well, Cameron, as well, for coming on today.
Yeah,
Thank you very
no
much.
worries. Thank you ever so much. And just like I mentioned on the last video as well, Abdallah does also do tuition. Do you want to just mention that again, just for those people that didn't maybe see the last video?
Yeah. So I offer like private tuition actually for like Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths and further maths for the pure section. Okay, feel free to drop me an email. My email is going to be in the description. It's abzw65@gmail.com. Feel free to get in touch with me, and I'll be happy to offer face-to-face or online tuition. So that is about my private tuition, guys. So thank you very much.
Yeah, and I also just put up his email up on the screen now. Is that correct?
Thank you very much, Cameron, for that. So thank you for that, Cameron. I really appreciate it, buddy. So thank you very much, buddy. I appreciate that. Or sorry, it is W6. Sorry, it is a W after the Z. Sorry, yeah, sorry, apologies. Yeah.
No, that's all right. That's all right. No worries.
I nearly made a mistake there. You probably sent it to the wrong email address, guys.
You know, people getting emails about some other tuition.
Yeah, basically, yeah. But thank you so much for watching, guys, and thank you as well, Cameron. I really appreciate working with you, buddy. So thank you very much.
No worries at all, mate. Really appreciate it. Thank you for this to be able to work with you on your channel and everything like that. So thank you guys for watching. That's all I've got to say from there. Any last words, Abdallah?
No, I haven't got any last words. No.
I haven't. All I've got to say is peace out, guys. Enjoy, and yeah, thank you for watching.